Back to the twin during my lunch break, too. You guys get that, right? You lazy kids, do you get that? This is my lunch break. Let's see here. I actually had to stop earlier because I noticed that this one had a mistake and I had to correct it before I went to the copier. Uh, this one's kind of an odd problem. There's probably lots of ways you can rewrite it. One thing, and I can't guarantee, the goal of this one is actually to be done by factoring by grouping. You could do x to the fourth minus 20x squared plus 64, but that's not the purpose, so that's not the point of the problem. And so whatever's on the test, you won't be able to do that with this one. I hope you get that, okay? The goal is to make a kid do factoring by grouping. That's the goal. So we're going to pull an x squared from the first two terms. When we do that, we're going to have x squared minus 16. And this factor has to repeat. And to make x squared minus 16 from the last two things, you have to pull a negative 4. Now, this might be an option. It's probably too easy to be an option. All right? What likely is an option is x squared minus 4 times x squared minus 16. I would say for sure that's one of them, okay? Finish the factoring by grouping technique. And whatever I create is probably something that you can keep factoring. My goal here is complete factorization. So x squared minus 4 is kind of like the first problem. It's an a squared minus b squared pattern. So is x squared minus 16. And this isn't the first time you've factored either one of those two things. You just forget or you don't do in the first place. But x squared minus 4 is x minus 2 times x plus 2. And x squared minus 16 is x minus 4 times x plus 4. And that would be the other factorization. And this is going to be multiple choice. It's going to be multiple select. You don't get partial. There ain't no partial on that. There ain't no partial on the end of course test. There ain't no partial on that test. Number 5, using the remainder theorem, determine which of the following are factors of x cubed minus 8x squared plus 11x plus 20. So all this means, and when you see me do this, I'm going to use a TI-84. I'm going to take my factor, I'm going to find my x value. X is negative 2. 2x minus 1 is 0, x is 1/2. X is 4, x is negative 4, x is 5. And then 2x minus 5 is 0. So that means that the x value is 5/2. I'm actually going to use a storage feature and just crank it out real quick. I'm going to store to x and then evaluate in the TI-84. That's all I'm going to do. It's the quickest way to do it. And the remainder theorem says, by the way, remainder theorem, because you've probably forgotten it, you've probably only written it down once in your life, says if f of a constant is 0, then x minus the constant is a factor. That's what remainder theorem says. So anyways, first thing I'm going to do is I'm going to take a negative 2, I'm going to store it to x, because that's the first, sorry, it's right there. I'm going to type in the z polynomial, which was x to the third minus 8x to the second plus 11x plus 20, and I'm going to press the old enter key. No. Turns out f of negative 2 is negative 42, not a factor. And I'm going to move on with my life. I had a half, store it to x. I'm actually pressing second enter. You can also use the up arrow. Turns out that f of a half is 23.625, so not a factor. Take 4, store to x, second enter, second enter. Turns out that f of 4 is 0. Found one. Negative 4. No. Not a factor. This will also be a multiple select question, all or nothing. Turns out f of 5 is a 0, so found another one. And the last one, the x value was 5/2. Add, divide by 2. It's actually quicker for me because I'm a little bit old school. I don't actually like to press the up arrow. I just know y'all are different. I actually do second enter, second enter, second enter. It's quicker because I don't have to take my hands off the keypad. Turns out that f of 5/2 is 13.125, so not a factor. You don't have to know much to do that problem. You don't really have to know algebra to do that problem. Hopefully you have some luck at it. Use synthetic division or remainder theorem for that matter. Determine if x equals -2 is a factor. State why or why not. This will not be done like that on the test. You will need to find the quotient. Anyways, it needs to say to determine the quotient. It'll be worded. It'll be about the quotient. Okay? We'll find out. We have x cubed plus an x squared. There's a placeholder, 0x minus 6. And if we're doing if x minus 2 is 0, then x is 2. We always actually divide out whatever the x values are. If you want to know why, I just don't have time to teach this in class. Google it or check, just Google this, type in Purple Math synthetic division. And they have a very good write-up on why it works. I just don't have time to teach it. We drop, we multiply, and we add. We multiply, and we add. And we multiply, and we add. Uh-oh. It's not, is it? I'm going to double check my work here. 1, 1, 0, -6. Drops 2, 1, 2, 3, 6, 12. Yeah, it looks fine. Here's my remainder, here's my constant, here's my x squared. So this becomes x squared plus 3x plus 6, that's my quotient, plus 6 pieces of the original divisor, x minus 2. Not a factor, by the way. Long division. Hopefully I can finish this before 6th period comes in here. So simplify using long division. Pretty sure I messed up one of these in the homework when I did the homework. It says write your answer as the quotient plus the remainder divided by the divisor. That's just the way we do things. It's a standardized thing. Need a placeholder for x cubed. See the jump? 4 to second. It's probably pretty small on your end. And I'm going to turn x squared into 2x to the 4th by multiplying by 2x squared. And then I'm going to distribute. 2x to the 4th plus 4x to the 2nd, or sorry, plus 4x cubed minus 2x squared. Subtract. Subtracting, by the way, is addition of the opposites. That's what subtraction is. There will be no x fourth. There's a negative 4x cubed, and there are no x squareds, right? Because they canceled out. To turn x squared into negative 4x cubed, I need a negative 4x. So negative 4x cubed minus 8x squared plus 4x, because I am distributing. Need to bring down that x there. I actually do need something there. And I am going to add the opposites. That's what I'm doing. I'm adding opposites. All right. There are no x cubed. There is 8x squared. There is a negative 3x. And then I'm going to drop down to 4. Thankfully, this is the last time I have to do the long division algorithm, because I'll be done after this. I need to multiply by 8, 8x squared plus 16x minus 8. And I need to add the opposites. No x squared looks like a negative 19x and looks like plus 4. And there's my remainder. So plus negative 19x plus 4 pieces of x squared plus 2x minus 1. I might write this out like the EOC. I might. If I do something like this and I notice it comes out to be like that, there's a good chance I'll write like the EOC. And it would be 2x squared minus 4x plus 8 minus 19x minus 4, because I pull the negativity from both pieces here, over x squared plus 2x minus 1. See, the subtraction symbol is in front of the fraction. It's no longer in the numerator. So I pull the negativity out of the numerator to make this true. And I would say I probably need to stop. And so there's 4 more problems on that twin. I've already done all the bonuses, so I'm making good progress. Probably won't do any more today. It's just Tuesday. I'll probably do more tomorrow.